Question 44. A cliff on the bank of a river is 87 meters high. That's a cliff on the bank of a river is 87 meters high. A boat on the river is 22 meters away from the foot of the cliff. Calculate correct to the nearest degree the angle of depression of the boat from the top of the cliff. The question says the cliff on the bank of a river is 87 meters high. So let's say a vertical line, which is a cliff, is 87 meters. It says a boat on the river is 22 meters away from the foot of the cliff. So we have 22 meters away on the sea. You have a boat, this is 22 meters. So we have our boat here. Then we know this is a right angle. This is like a right angle triangle question where we'll apply Pythagoras Theorem. So we'll just draw a line that joins them. It says, calculate correct to the nearest degree the angle of depression of the boat from the top of the cliff. You know, the angle of depression is always from the horizontal. So we'll create dotted line on the horizontal, then we'll make an angle. We've been asked to find this angle. The angle of depression is always to the horizontal. It's not here, but it is here. So you make it to the horizontal, this angle. And if you know, this line should be parallel to this. Therefore, if this is theta, this is also theta. This angle is also theta. You should know that. That's why there's a saying in the textbook that says the angle of elevation, particularly in this kind of setting or in a right angle triangle, is always equal to the angle of depression. So when you have your angle of depression, you can also find your angle of elevation. So once you find the angle of elevation, you're also finding the angle of depression. So this angle theta here is same thing as this angle here. This is called alternate angles. It forms a Z, if you see. So this internal part of a Z is same as this. Rather than transfer this also to this side, we'll still get the same answer. Let's just leave the shape the way it is. Then we know once we've found this angle, we've also found this angle. So we'll solve to find the angle, and this is where Pythagoras Theorem comes in play. Now we're looking for the angle, and we have the line facing the angle is the opposite. This is the opposite. The line facing the 90 degrees is the hypotenuse. This is the hypotenuse. And the last is the adjacent. This is the adjacent. We've been given the opposite and the adjacent, and we're asked to find the angle. And the relationship between the angle, the opposite, and the adjacent is tan theta. So we have our tan theta equals opposite over adjacent. Tan theta, our opposite is 87, our adjacent is 22. Tan theta equals 87 divided by 22 will give you 3.95. Now move our tan to the other side, leaving our theta behind because we're looking for our angle, which is theta. Theta equals arc tan 3.95. Using our calculator, pressing either the second function button or the shift button, we press tan, then 3.95. It gives us 75.8 degrees. Our answer to the nearest degree as demanded by the question is 76 degrees, because we are trying to make it to the nearest whole number. When we want to take away this 8 through approximation, once you're taking it away, you add 1 to the number in front of it. You now have 76 degrees. Our answer is therefore A, 76 degrees.